result in a lot of confusion. Students in a school are allocated to classes based on the age group they belong to. It is because students in a class are likely to have similar attributes in terms of the level of knowledge, capabilities, height, and weight. Similarly, there are over 100 elements known to us. Scientists felt the need to classify them on the basis of some common properties. Very broad level. A large number of elements were classified as metals. However, they did not necessarily display similar chemical properties. For example, sodium and copper were both characterized as metals, but their chemical properties are very different. Some elements, such as boron, exhibited the properties of both metals as well as non-metals. It was difficult to determine how to classify such elements. After further research, a German scientist, Daubernier, arrived at a hypothesis in the year 1829. According to Daubernier, all elements occurred in groups of 3 when arranged in increasing order of atomic number. The arithmetic mean of the atomic masses of fluorine, 19, and bromine, 80, which comes to 49.5, varies significantly on scale. Consider the list of elements with their atomic weights in increasing order. Starting with lithium, the 8th element from lithium is sodium. Similarly, the 8th element from sodium is potassium. Lithium, sodium, and because it was not valid for elements of atomic masses higher than calcium. Newly discovered elements could not find a place in Newland's table. Periodic function of their atomic masses. Let's look at the features of Mendeleev's periodic table, widely accepted as a system of classification. However, it did not achieve complete success because of some demerits. The table had some inaccuracies. Is a better basis for classifying elements than atomic weight. On the basis of his work, he developed the modern periodic law. The modern periodic law states, the physical and chemical properties of all elements are periodic functions of their atomic numbers. The modern periodic law has become the universally accepted form of classification of elements, as it does not suffer from the demerits of Mendeleev's periodic table. Was intended to illustrate the arrangement of elements using atomic weight as the basis of classification. However, this arrangement showed some anomalies, like elements with higher atomic weights were placed before elements with lower atomic weights. For example, the atomic weight of cobalt is 58.94 and that of nickel is 58.68. However, the Mendeleev's periodic table places cobalt before nickel. Such anomalies were resolved when the modern periodic law designated atomic number as the criterion for classification. In this lesson, you will learn in detail about the modern periodic law. The modern periodic law was developed by Moseley, an English physicist. This law states that the atomic number is a better basis for classification of elements than atomic weight. This law formed the basis for the modern periodic table. Atomic number is the number of protons in an atom. It is also equal to the number of electrons in the atom, since an atom is electrically neutral. For example, the sodium atom contains 11 protons and 11 electrons. Therefore, the atomic number of sodium is 11. Similarly, the atomic number of magnesium is 12. Since the